everybody here?
I'm here.
I'm not.
I can't see a thing.
Yeah, right.
You just have to do it on faith.
Okay, we're going to roll it. Our next speaker is William Hartman, and the title of the talk is The Beauty of the Solar System, a title that I wrote. And he's a senior scientist at the Planetary Science Institute in Tucson. He is an internationally known scientist, writer, and painter. His research involves the origin and evolution of the planets and the planetary surfaces and the small bodies of the solar system. Recent awards include, if I can pronounce them correctly, Runcorn Florensky Award Medal from the European Geophysics Society for work on Mars, crater chronology, the Lucian Rudix Memorial Award from the International Association of Astronomical Artists for lifetime contributions to astronomical arts, and the G.K. Gilbert Award from the Geological Society of America for outstanding contributions to the fundamental problems in planetary geology. And I should mention that part of the reason this conference even exists is because of him, because many years ago, probably in 1983 or in 1982, I read an article he wrote in the Smithsonian in which he lamented that he had written an article that nobody would publish. And so I said over and over again, send it to me, and he didn't, and so finally he did, and then I published it, and he said, thank you for keeping after me. And so I was actually inspired by the article, and it led me towards doing the first environmental ethics and the solar system conference. So this is the guy who started it all.
So I apologize to everybody for that. Yes. I don't know if this little guy is on. Maybe.
Yeah, that's just for me, actually.
Okay. Oh, sorry. Which probably means you don't like me banging on it. And this is a special talk because this will probably be the last slide talk you ever see in your lives. And as Gene said, he chose the title about beauties of the solar system. So I was out there, collecting slides, Selma Hayek and Catherine Zeta-Jones and Kim Basinger, and Jerry Ryan certainly, who was 7 of 9 in the Voyager series, because that would establish the tie-in to space exploration. When I realized you were actually talking about paintings and aesthetics of planets and rocks and things. And so how do you say anything very meaningful about, what defining beauty or defining the beauty of the solar system or defining art or defining science or how they're related, all of those questions. So what I'm going to do is I tried to think up a couple of themes, at least generally about that, and intersperse them with a few slides. So first of all, I want to talk about theme number 1, which is that as I was thinking about this, I think that our concepts of beauty come out of, at least in part, out of the sort of current paradigm, the zeitgeist of the time. There is a link. I mean, there are things that are, this issue of, are there things that are intrinsically beautiful to us? And on the other hand, isn't there a cultural influence? And there certainly is some cultural influence, which I think a lot of us don't realize. And my favorite example, which has to do with planets, is in the late Middle Ages, the Earth was seen as having started out in perfect condition, Garden of Eden and so forth, and basically having run downhill. And the mountains were the wrinkles of old age, or as I prefer to think of it, the beginnings of kind of middle age. But, so the Alps in European culture up in 1400s and 1500s were actually perceived as rather repulsive. And there's some wonderful descriptions of the horrid mounds and excrescences of the earth and so forth. These are, the wrinkles and destruction on the planet Earth. And it wasn't until after the Romantic Revolution, 1800s and so forth, that suddenly, we see, oh, the glories of the Alps and climbing in the Alps for fun and all of that. They were seen as an impediment to travel. It's a fun question to think about in terms of music, too. I mean, do I like Rossini's William Tell Overture because of the rhythm, or because the big theme was on the Lone Ranger, which I listened to as a kid? We all like the rock music that we grew up with, but we don't like the current rock music, but somebody else likes the current rock music. So I think the paradigm that we're operating under, especially us, it has to do with exploration and empiricism and discovery, finding out things that we didn't know, being on the margin of between knowledge and not knowledge. And for me, getting into it, as I remember, was my brother had a book of knowledge encyclopedia set, and I used to go through those and discovered this map of the moon, and the moon had named places on it. It wasn't just this silver thing in the sky. It had names, and to me, I think that must have acted a lot like, for kids today, for instance, like The Lord of the Rings or something, where you have this mythical other kingdom that's exciting, except that it was real places in the sky. That I guess has been for me one of the attractions or the beauties, is watching well, you might say watching those maps fill up with features and names for the different planets, and which is a kind of a roundabout way to get into painting, because the experience of painting is dealing with a specific place, and I like to go out and just plein air painting, which is outdoor painting, and sometimes actually go to places that are like other planets, volcanic or cratered landscapes and so forth, and then paint that, but change the colors and take out the bushes and make a Mars painting or something of that sort. So I'm going to start by giving you a little background, just a quick little snippet of the history of the artists, the astronomical artists, the space artists who are doing some of this sort of thing, and where that thread has come from. It's going in painting. And a lead-off little quote, I was actually seeing an exhibit of the Impressionists, the French Impressionists, who incidentally were interested in the science of light. I mean, we think of them as these sort of gauzy, vague, fuzzy paintings, but at the time they were very interested in the new theories of the spectrum. That was the whole reason that the pointillists came in, because they were dealing with the little dots of color, trying to represent what people had discovered in the spectrum as being made up of lots of different colors. They were trying to get that effect on light reflected off of paint. And anyway, Sicily had there was a phrase on the wall in this particular exhibit of actually he was English, but he worked with the French Impressionists, that every picture, meaning paintings, shows a spot with which the artist has fallen in love. And I really like that idea. So let me run through, and let me do this. A lot of the artists who are doing this kind of thing, and particularly the American community of them, although now we're kind of scattered around the world, trace back to, well, what really started as the Hudson River School in the mid-1800s, and this was Frederick Church, his painting of Niagara Falls, which at the time was sold for the highest price of any American painting somewhere, I think, in the 1850s. And the next slide is, Church would actually organize his own expeditions to go out to exotic places. He did paintings in the Arctic Ocean. There's a famous iceberg painting. This is Cotopaxi in Latin America, erupting volcanoes. And then we had, as the frontier moved west, Thomas Moran was out. Those early expeditions to the western frontier took artists along. Thomas Moran went on the expedition that sort of studied Yellowstone Park, and did a lot of watercolors like this, and then came back and did enormous paintings, maybe 8 feet or 12 feet, that you can still see in the National Gallery and so on, and showed these on the East Coast, kind of proclaiming the wonders of what was out there on the frontier. To me, very analogous to where we are in space exploration today. And we get the pictures back from Voyager or Cassini and so on. If you look at his signature, and in the next picture there's a blow-up of that, there's a Moran a T and an M, but see there's a Y in there because he became known as Thomas Yellowstone Moran for going out there. Why? Because President Grant, after they came back, declared Yellowstone the first national park, basically on the strength of Moran's paintings that he brought back, you know, to demonstrate the beauties of what was out on the frontier. So that's a great link between the sort of the beauty concept on the frontier and the actual creation of the American park system, which has been a model around the world. And let's go on. And finally, Albert Bierstadt got all the way out here to California. And next in France was Lucien Rudeau, around the 20s, who's considered kind of the granddaddy of, you know, serious attempts to paint other planets. He had his own little observatory. He wrote popular books. This is a really interesting picture because this is a view on the moon. And look at that rounded profile. Now, you know, throughout that time and all the way up into the 60s, the general picture of the moon was those big craggy rocks because people looked through telescopes and saw those long pointy shadows and thought, gee, there's all these spire-shaped rocks. But Rudeau actually studied the profile of mountains on the limb of the moon and realized that they were rounded, so he was way ahead of everybody on that. Next. And I think he did the first attempts to paint. You're flying in your 747 over the clouds of Saturn up at the latitude of San Jose, and you look out the window with a very wide-angle lens, and those are the rings as seen from an upper middle latitude with the shadow of the planet on the rings and some of the other moons. In the 1800s, you know, lacking adequate spectroscopy and so forth, what they did a lot of, and you can go find the old books on university libraries or old bookshops and page through them. They were fascinated by all the geometry about Saturn and its rings, and had already realized the rings were made of particles. Keeler showed that by showing that the inner part of the rings was rotating faster than the outer part. But, you know, didn't have too much else to do, so there was a lot of interest in the geometry. Now, the descendant of Lucien Rudeau is a guy named Chesley Bonistell, and how many people have heard of Chesley Bonistell? Right. So this is the most famous image of his and a really pivotal image in the history of the space program, I think. It's striking to me how many of the engineers who put Apollo on the moon had that book as kids, and I had it. It was 1949, I think. And when I was, you know, like 10 or 14 or so, you know, and you know, it created that image. And Jules Verne said, "What one person can imagine, another person can do." And I think that was the role of artists in giving us an image of what might be out there, especially at the beginnings of the space program. And now it's probably getting a little bit more practical, as some of the discussion I heard. My flight was arranged actually before we moved the talk up till today, so I only came in this afternoon, but I heard a little bit of the tail end. And there's all those craggy rocks. So there's Bonistell painting the craggy mountains even after Rudeau, but maybe only Rudeau, had pointed out that a lot of the moon was rounded off, which was kind of the sandblasting of all the little meteorites. So Verne says, you know, what one person can imagine, another person can do, and there's that silver rocket on the moon, and I think that really was an inspiration. Also, I like to relate Martin Luther King to this, Martin Luther King Jr. You know, I have a dream. He doesn't say I have a blueprint. He doesn't say I have the blueprint that's going to tell you how to do this. But, you know, the artist, the visionary has the dream. And next, I met Bonistell. This is an 80 picture when he was in his 80s. There's the famous picture of Saturn that I'm going to come to. And next, he was actually trained as an architectural draftsman. And in the 40s, he was the highest paid matte artist in Hollywood. That when they did the special effects by doing background matte paintings or small paintings, which were then dropped in front of the camera. So he told me, for instance, you know, he worked on Hunchback of Notre Dame. He paints everything above the first 10 feet of the cathedral scene from camera angle, and that's dropped into the top of the picture, and then the actors work in front of the bottom 10 feet that's a set. And he also worked on I was going to say Hunchback of Citizen Kane, that's not right, Citizen Kane. But this was his own globe that he made of Mars in the 40s when he was doing some of that sort of thing. He was always fascinated by astronomers, but it was his architectural drafting that got him into figuring out all these angles and what would Saturn look like particular satellite, and so on. Next. So that did kind of lead to this realist school of space art. Now, here's a guy who's actually been to the moon. That's Alan Bean. And what do you do when you come back from the moon? What career do you start? So he actually took up an old interest in painting. And I think you have to be an engineer, astronaut, precise type of personality to actually paint in your living room on the gray carpet. I don't know of any other artists who do that. And actually, this was for one of the guys who was the third guy who orbited the moon up in the capsule. So you see there's the Apollo lander, and there's 3 astronauts there because he was saying, okay, you could have been down on the surface. And you notice this guy's holding his 2 fingers up over the other guy's head. Next. This is another Bean painting. I don't know, it may focus a little better, but just start looking at colors down here. I want to get you thinking about the meaning of what are we really painting, or what would we really be visualizing if we were trying to create an image of another planet. And I actually talked to Bean a little bit. Oh, the funny textures in here. What he would do, he would put down a very thick coat of what's called gesso, sort of the undercoating, underpainting. And then he had some of his tools and the boots from the lunar exploration. And so there's a faint boot print on here. There's little imprints of some of the tools that he used. But he would talk a lot about what color am I going to paint the moon? And think about that, because you might start out saying, well, we know the moon's like 10% albedo and it's dark, it's like dark gray basalt, and so let's get that color paint, and that'll be authentic, that's the real color of the moon. You do that, it looks terrible. It's a terrible picture. It's all dark and muddy and gray. Quite a fan of Monet and the Impressionists, and in some of his different paintings you can see this to different amounts, but you notice there's like warm brown tones and blue tones and lighter tones. So it's this whole technique of mixing a lot of other faint colors in, and you back off and see that as a more lively kind of a gray. It still looks gray. And remember that even though the moon is actually made of dark material, especially in the lava plains, the astronauts, when you talk to them, talked about, this brilliant, I think Schmidt said something about it was like landing in an alpine valley. They were on the last flight in Apollo 17 up near those hills. But you can explain that to anybody, because if you go out in dead of night and you're standing under a bright street light like that thing and look down at the dark asphalt, it looks very bright, and you can't see very many stars. So where I'm going with this discussion is sort of the idea of the human perception. And have you ever walked into a museum and seen a painting that's obviously, you know that painting's at night, or maybe under a cloudy sky, but imagine one that's at night. And sometimes they put in stars so you can say, okay, that's how I knew it was night. But not always. I mean, you can tell across the room. And this is very strange, because if I've actually done the following. If you take your camera out, used to do this with good old Kodachrome film. See, I'm a slide guy in Kodachrome film, all this historic stuff. And time exposure at night. And it comes out, if you take about the right exposure, it comes out the same colors as daytime. I've done that under moonlight. But the next slide is what Frederick Remington did around 1905, night. Now, aside from the stars up there, how do you know that's night? And what Remington is kind of famous for is inventing this color, this kind of greenish gray color scheme, which actually has physiological reality, because our color vision goes, especially the red, is that the rods or the cones? I can't remember. But we don't see the full color perception at night just because of our own physiology. So the same kinds of things. You imagine painting Pluto and you're 40 astronomical units from the sun, and it's I remember Arthur Clarke talking once about the satellites of Jupiter, and I think when you work it out, I think he said this, and I think this is right, that the light level there is like in a reasonably well-lit interior room, and Pluto would be fainter than that. But do you make the painting all dark, or do you do what the astronaut would do and actually compensate and take a longer exposure, so to speak, and make it look the same? So those are kinds of things that you think about, is what is it really like to be there, and what is the relation of this to making a beautiful painting and so forth. Let's try the next one. Yeah, I just wanted to say quickly that a group of us who are interested in this, a lot of them are magazine illustrators, but they've been painting, and we formed a group way back in the 80s, and a lot of them hadn't met each other, but we went to Hawaii Volcanoes Park and all hit it off, and this has grown into an international group of several hundred people. So we have workshops. The next picture is painting in Iceland, and the next picture is painting in Death Valley on our favorite spot called Mars Hill. If you go up to Death Valley and you Artist Drive is, if you were coming out of Artist Drive into the north T intersection into the north-south road there, go right across the street, just park your car there and go walk up that little rise. It's one of the most Mars-like distributions of boulders that we've seen. Next slide. So we go to places like that and we paint. Now, I like to point out that these guys are very clever, and all of the space artists I met are really fun, and they're a good sense of humor, and they're smart, and they're clever, and they know a lot about space, and are often different, a different approach to things than the scientists themselves. But one of these guys is Joel Hagen, who lives here in California. It's all California's fault. We were in Death Valley. So he went out and printed up. Now, isn't this definitely, doesn't this say U.S. government type style somehow? So he printed up these national park looking signs, which explains that you've got to be very careful in Death Valley if you throw out your lighted cigarette or cigar, because there's these deposits of flammable minerals which have formed due to the arid conditions, and you could catch the whole valley on fire and cause a hazardous sand fire. And he snuck out at dead of night and stapled these up on signposts around the various parking spaces, and then would come back the next day and listen in when, Harriet was, George, you better put out that cigar, because it says here. And it was very naughty to do. But he, this was during one of our workshops. And later on, he came back, I guess a year or two later, and was at the headquarters, and sure enough, they had some of these pasted up in the ranger's office. Next. I, of course, had nothing to do with this. This is an illustration from Leonardo Da Vinci. And Leonardo was a great guy. He had an inspiration to all of us, because he would start all these books and never finish them. And one of them was on painting. And I just talk about the kinds of things that he was already aware of. This is an illustration about colors in shadows, light bouncing around. So imagine this is a canyon, and here's a red hill over here and a red hill over here. And what he remarked was the sunlight's shining on this bright sunlit side of this red hill. So that reddish light from that red hillside is shining across to the other side of the canyon. So you've got red light illuminating the shaded side of the hill. So it's definitely dark, but to put it in artist tones, it's darker, it's lower value, but the chroma, the intensity of the red, is sort of squared, multiplied, because it's red light on a red surface. And sure enough, it's quite amazing if you're making a painting, especially like up in the Red Rock country or the Grand Canyon, and you feel, your first instinct, I used to get out my black and darken down the colors. Terrible, it doesn't work. But I finally learned from reading Leonardo's book that in some bright red tones in those shadows, and it really brings the whole painting alive, and light is bouncing around. So this is by way of saying that a lot of the painters are seeing, in my mind, they're seeing real science, they're seeing real physics, real effects of nature. But they just aren't the same effects that most of us planetary scientists study. And that whole thing intrigues me, because I suppose when I was in high school, I thought that science covered 94% of all the phenomenology that we have in the world, and we're out there studying it all. And now I think it's more like 10%. And I'm particularly intrigued when I go out with the painters, because they have real working knowledge of all kinds of phenomena going on, the colors of clouds and all the stuff that you never really hear about when you're reading a physics book or studying in college, in science courses. Which comes to theme 2, and this is between the two sets of slides that I have, that I think that some of the aspects of beauty when we're exploring the planets comes not just from the intellectual knowledge that we have of them, but what I like to call experiential knowledge. And what I mean by that, my example is, physicists could really know a lot about playing tennis, and they could understand the angle of the ball and the rebound racket and the coefficient of restitution and have absolute mastery of all of that and be a terrible tennis player, right? So being a good tennis player involves some other kind of knowledge, which is body knowledge, is what I'm calling it, as opposed to head knowledge. And I like the idea that in science we can bring both of those together. And the example I have is having been on several imaging teams on Mars missions, that I've actually been in imaging team meetings and noticed this funny thing where suddenly we have a picture of, maybe some sand dunes and some funny erosion at the edge of these sand dunes. And so particularly the scientists who, like myself, grew up in the East. I grew up near Pittsburgh, under the leafy trees and the grassy soil, are looking at those pictures, and pretty soon they've got envelopes out and they're working on the back of the envelopes, the wind velocities and the saltation heights, and then maybe theoretically these sand grains could erode this hillside or something. And I'm looking at the same pictures and thinking, gee, I was just camping in a place like this in Arizona about 2 weeks ago that had the same kinds of features. And that strikes me as two different kinds of knowledge. And the more we can kind of integrate those, I think the more we're susceptible to, the beauty, the joy of the kind of places we're studying. And another example of that was years ago, it was discovered that the satellite Io of Jupiter has sodium atoms coming off, and they're excited by the sun, and there's this aurora, this yellow sodium glow aurora around Io. And I was at a meeting where a friend of mine, the funny thing is I can't remember which of several friends this could actually be, but anyway, an observational astronomer, was giving a discovery paper of having actually gone out and measured this. I mean, it had been discovered, but it hadn't actually been measured, and he was able to detect it with photometers and actually measure the brightness. So he's giving this 15-minute paper, or whatever it is, and comes to the big bottom line after spending, some months having gone up to the mountain and observed and come back and gone through all the analysis. And the answer was, it was 20 kiloreles. That's the number I'm remembering, kiloreles. And I'm thinking, kiloreles? I have no idea what kiloreles really are, or what 20 kiloreles would be. But I'm sitting in the audience thinking, all of us space artists are tired of painting all these black skies. Gee, it would be neat to paint this Io with a yellow sodium aurora. Could a human being actually see that up in the sky? Which comes again back to this idea of, at least in where I've come out in my painting, is trying to paint, trying to visualize scenes that human beings would perceive, okay, as opposed to like painting in infrared or something. So I go up afterwards and say, you just said 20 kiloreles, and can somebody actually see that? And his mouth dropped open, and he had never thought about that. And I thought, that's actually strange and interesting when you think about it, that we could spend 6 months of our careers going out and measuring something in order to get the numerical value, and never understand whether it's how our bodies would perceive it. So again, I'm trying to make that link with sort of body knowledge. Another example, unfortunately, I'm as guilty as some others, Clark and I, probably both. In the 80s, I did a lot of work in Dave Morrison, but he isn't here, working with Dale Cruikshank, who's here at Ames, on colors of asteroids. So we're always coming up in this astronomical system that the difference between, how's color measured, difference between the red intensity and the blue intensity, for example, would be 0.197 magnitudes. Terrible system already using magnitudes, but what does that mean? And so we've all been publishing colors, red minus blue, yellow visual, or yellow minus red, and et cetera, et cetera. But nobody can tell you what that set of numbers means in terms of what you use, which is kind of interesting. And some of us have kicked around, we should really get some paint chips and measure them and figure this out. But to my knowledge, that hasn't actually been done. I mean, we know these things are kind of reddish brown, the ones that I'm thinking of, but it isn't exactly clear whether they're like a chocolate bar or a little redder than that or what. And I guess all of that's why I like going out and painting from nature and sort of experiencing what I'm seeing, as opposed to just painting in the studio. It's really fun. And again, the Sisley quote, every picture represents some place that the artist fell in love with. I used to do a lot of photography, but I began to feel like I'm only actually interacting with the place for 125th of a second. And you could go out and sit there for 3 hours under the sun and paint it. And practically every painting, I can come back and I can look at that and I remember exactly what was going on that time when I was sitting there doing that. I sort of feel like I've really interacted with that landscape, and it's come my eyes and through my brain and down my arm and out onto the picture. Body knowledge, not just head knowledge. So some more examples of the pictures. Earth light on the moon in a crater. We can go through these quickly. Most of these are mine, not all of them. That's on Mimas, looking at Saturn coming up over the horizon, icy landscape. Next. We can go back and paint the origin of the solar system, the early Earth and the moon, with the moon passing in front of the sun. Lots of comets around at that time. What's fun here is to synthesize, to take all the kinds of knowledge that we have, whether that's photometry of T-Tauri stars that have those little disks of dust around them, or the studies of the origin of the comet clouds, and things were being perturbed all over the solar system during the formation of Jupiter and the outer planets, and there were probably a lot more frequent comets in those days. The sun, as well as other stars, typically forms in a cluster in a star-forming region, which is full of nebulosity, like the Orion Nebula. So in the early solar system, in the background, you'd have nebulosity. And putting all that together and trying to make something beautiful out of it is a challenge, I think. Next.
That's backwards.
It's terrible. Yeah, that's right. Actually, everything is exactly the opposite. Yeah. In fact, everything I say is often it's the opposite. Let's go on quickly before we get mired down in my backwards. This, you remember Bonistell's rocket ship? So I had some fun one day I'm going to paint his rocket ship, which is the way rocket ships are supposed to look, but put it on the moon the way we actually found it. And as my artist friend Ron Miller said, the fact that the moon didn't actually look the way Chesley painted it wasn't Chesley's fault, it was the moon's fault, is what Ron says. And curiosity, just to show you the mindset of a lot of these kind of artists who are doing this sort of thing, is that while I was doing this, one of my buddies in England, who's in that group that I showed you, which is incidentally, it's called the International Astronomical Artists Association, IAAA, and you can go find that on the web, IAAA.org, I think it is. But David Hardy in England had the same idea, except what he did is really funny. He did Bonistell's moon, basically on kind of the left side of the picture, and the actual LEM lander. So he did sort of the reverse of this version. And then he sort of faded it so that by the time you get to the right-hand edge, you can actually see the moon more the way it actually appears in reality to the astronauts. But the rocket and the funny little instrument, well, I don't know what that instrument was, but it's in Bonistell's painting, and it's got a wooden leg tripod that they took. And so that's what moon exploration was supposed to look like. Next. Okay, Titan. One of the things that space artists can do is give us a record. I think this relates to aesthetics and the beauty of the solar system. It's a record of what we thought those places were like in each decade. And I was just talking about synthesis. To make a painting like this, you sort of understand what the astronomers think is going on. And Bonistell, this was 1944, 44, 45, 46. Kuiper, my professor, Kuiper, Gerard Kuiper, had discovered that Titan has an atmosphere. What he detected was the methane. And so Bonistell, who I think actually talked to Kuiper, but anyway, he flashed on the idea of the blue sky. We can see this beautiful pattern hanging there in the evening blue sky on Titan with this frigid snow and so on. So this is Bonistell's Titan as of 46. Now, if you just go around to university libraries and hunt up issues of the Astrophysical Journal, which was practically the only that and the Astronomical Journal, the main two journals at that time. None of the planetary journals existed yet, Icarus and so on. And you try to go through and figure out, what did people think Titan looked like. You'd have to read, one astronomer's talking about spectroscopy and somebody else is talking about photometry or polarization and so on and so on. And how do you put all that together from the dry scientific language into what they might have actually thought it looked like? But the artists can do that. So Bonistell did that for us, 1945. And then we start moving forward. By the 70s, there was some evidence beginning to appear that there could be clouds on Titan. I think it had to do with maybe some polarization. So the next slide is by a young artist named David Eggy, who I think was 17 at this time and self-taught. But this is Titan, kind of inspired by Bonistell, but we have some clouds up there. And the next slide, oh dear, Voyager actually passed Titan, and it's completely covered with this apparently opaque reddish smog, like Los Angeles. So the next slide, that was one of mine, trying to say, okay, you're just above the atmosphere, maybe a nice icy volcano sticks through, but if you're flying above it, you can still get to see Saturn hanging in the blue sky with some more of those reddish clouds up there. And incidentally, some of the folks in our IEEA group coined a term that this level of the atmosphere, where you can still see a blue sky, the clouds, but you can see a blue sky on Titan, they decided to call this the Bonistellosphere, as opposed to the troposphere or the mesosphere. So the Bonistellosphere is where you can still see the blue sky. Next. And things began to look pretty grim when Voyager discovered that there was the right temperature for methane and so forth to be snowing out. But we all hoped that somehow you could still see a little bit of Saturn. So my buddy Ron Miller painted this with the methane and the methane liquid and the methane gas and hazy Titan just barely visible through the clouds. Incidentally, it was pointed out to me. I don't think anybody pointed this out in connection with the painting. I think it was at one of the DPS meetings that they were talking about the Cassini probe and would it land on ice or in a liquid. And somebody made the note that, remember, it's only water ice that actually floats on its liquid. So if this really is a methane ocean, this stuff probably would have sunk, although it's probably some low-density clathrate or something floating on the surface. So the next slide then is sort of the next phase. Oh, it's now so dark and gloomy down there that you can't see Saturn at all. Methane flowing around. And then the next slide, there's the Cassini probe descending. Jim Hervat painting, and the next slide we actually got down there to the surface and we finally saw it. But anyway, that's a nice succession. So I always say, for if there are curators of collections that have 20-year-old space paintings, they say, oh gee, this is all wrong, we should throw it out. No, because that's the historic record of the best view of what they thought that place looked like at that time. Next. Well, we can go outside the solar system. We can go to double stars. And then the next slide is what happens if you turn around and look the other direction and you're on a nice earthy planet, but it's a double star, so there's two rainbows. That was one that Pam did for a book of ours. Next slide. Or go into the center of the galaxy. It's one I did. Something I like about this kind of picture is everything that's in there is in there for a reason. Lots and lots of red giant stars, magnetic stuff going on near the center, probably some kind of black hole, neutron star, lots of big dark dust clouds. But it ends up looking kind of like an abstract painting, and yet everything is in there for a real reason. Next. Or you're off in a planet that's in another galaxy, it's in a galaxy that's colliding with another galaxy, so there's sort of the Milky Way. But then you've got another galaxy up, and where the two are intersecting, there's some nice excited hydrogen and so forth. Next. Oh, and then a kind of a fun topic about these synthesis ideas. Until Halley came around, and people started thinking about putting a probe down on the surface of the comet, the physical body of a comet was hardly ever talked about. It was really striking at meetings because the people who studied comets were the gas spectroscopists because they looked at spectra and so forth. So you had the one session, the asteroid session, and Clark would be over there giving a talk on the rocky objects and infrared spectra and olivine minerals and pyroxene stuff. And then that's on Tuesday morning. And then Thursday afternoon in a different room is the comet session. where there's all these gas spectroscopists who never ever talked about what it would be like to stand on the surface of a comet or float on the surface of a comet. Well, I had been up at Mauna Kea Observatory, and I had seen this effect as the snow kind of sublimes away and you get little rocks caught on it, and it makes little pedestals. And I thought, I guess we all thought at that time, this was kind of the Whipple model, that it's a dirty iceberg, and there's going to be some of this carbonaceous stuff in there, but as you lose a meter or so every time the comet goes around the sun, you're going to have all these little rocks stranded on pedestals. And I actually put this up at a Comet meeting. It was lots of fun to have the Comet experts come and stand with me and look at that and criticize it. And I actually felt it was sort of fertilizing some science to get people to think that way, as opposed to just the analysis of spectral lines and so forth. It was kind of, again, this experiential thing versus just analyzing what you can analyze. But the funny thing about this story is, so this was comet surface. We now know they're mostly very dark. I mean, they're entirely covered by that kind of stuff. But what happened after I displayed that was, you can imagine this is a great game of telephone. Other people are saying, well, how did this guy paint it? So the next picture is from a brochure that the Jet Propulsion Lab put out when they were pushing their image or their plan for a Comet mission, and the whole comet was covered by these little toadstools with the rocks. And the toadstools showed up on a number of comet paintings over the next 5 or 10 years. And they probably said, well, Hartman put them on there, so they must be there or something. I don't know. But it was kind of fun to see this sudden new official version of what a comet looks like that had absolutely no real science behind it, other than just sort of an observation on Mauna Kea, not through a telescope, by the way. And the next. So what are we going to do? Seems to me, getting back to the ethics of exploration, we can do this thing of division, what one person can imagine another person can do, and that's what this conference is about to some extent. And I think we're undoubtedly going to be doing things like this and going to asteroids and actually getting some resources. John Lewis is one of the guys who really pioneered those ideas, and the next slide shows the idea of even bringing one into orbit around the Earth and mining it. And the next slide, if you can get it to drop in there, I don't know if it'll drop in, but you can keep jiggling it. It was just a landscape in the forest, but yeah, there it is. But what I say to audiences is that I've had audiences sort of recoil at that point and say, oh, you technologists, you guys have ruined the Earth, now you're going to go out and ruin the solar system. But to me, the point to make is the opposite, that if we start utilizing the 24 hours a day of free energy that's flowing through space and visiting asteroids and maybe utilizing some of that as the basic raw material and over 100 years transport some of that heavy extractive industry off the Earth, then we can let the Earth start to relax back to its natural state. And that seems like a direction we'd really like to go. I had just one other comment that occurred to me, and I witnessed this afternoon, and actually you could bring up the lights, that I can see that this conference is already going to be going in this direction. But this occurred to me under the heading of beauty, beauty and as somebody was saying this afternoon, we scientists like to get these ideas out, right? We're proselytizing to other people about what we've learned, and to me that's kind of a sacred task, that humanity learns more. I keep telling people the environment is no longer just the meadow next door and the stream, it's at least the inner solar system is the environment of humanity now. So something that bothers me a lot, and I really think is probably the most dangerous thing going on right now, is the fundamentalist movement, which you also were already talking about this afternoon, all around the world. But how many people know about the book that is still being sold in the Grand Canyon, which says, I have to read some passages. How many have actually seen the book?
No, I've never seen it.
No. So you can come and look at it. I suppose I have to admit I actually bought it, but I bought it because I wanted to, see what was going on. But here's one part that's it's talking about the rocks that you see. This is way up front. I mean, you could practically pick any page in here. But so we're talking about what was laid out in the Bible and other historical documents, and this all occurred 6,000 years ago. This is the form. and the formation of the canyon, I guess, for that matter. The vast majority of the sedimentary stratas that we see in the Grand Canyon, and in the rest of the world for that matter, were deposited as a result of the global flood that occurred after and ultimately as a result of the initial sin that took place in the Garden of Eden, and so on and so on. The fossils, this is a good one, the fossils, next sentence, the fossils found in the rock layers are remnants of the plants and animals that perished in that flood. Really nicely done book. Apparently it was sold in the natural history shelf until there was a big outcry, and what I understand now is it's still for sale but has been moved to a section on something like philosophy or religion or something like that. Not fiction, I don't think it said that. So, what is our ethical duty in response to all that? My answer is that what I've come around to, and this is partly from teaching a summer course every June in Hawaii, or part of a course, that we shouldn't be standing up and say, no, damn it, we've proved, we've got our radiometric measures, the truth is this. I think that's not the way to say it, because then we become fundamentalists. So I think the answer is to teach about the history of the ideas and where those ideas came from. How the approach is, how did scientists today get forced by the data, by empiricism, to believe what we believe? And when you start down that road, it's marvelously simple, because a lot of the ideas go way back. They're simple stuff. And in particular, this 6,000-year-old Earth is fascinating. I've written some material about this. I can't seem to get it published, just like I was telling Gene. But, of course, Usher made the famous estimate, 4004 BC, by totaling all the generations in the Bible. He was the first to do that. Already in Usher's 1650s, Shakespeare 1605, 1610, there's already a line in there about this poor Earth is only, I think it said 5,000 years old. So that idea had already been kicked around in the 1500s. It's just Usher did it best. And we shouldn't laugh at it. It's lots of fun to laugh at Usher, but I mean, that's a brilliant thing to do under the zeitgeist of the time, when you think that we know the Earth formed and Adam and Eve were created in a generation. If we could just tabulate all the generations back, if we had a good enough record, we ought to get the right answer for the age. So he does this. What was the best record? Well, the Europeans at that time figured that was the scriptures. And he actually measured something. He measured the age of human history. He just didn't measure the age of the Earth. It's the age of history. It's 6,000. It's not 10,000 years. That's too much. It's more than 3,000 years. So I'm an astronomer, I think, in factors. This is a pretty good measurement, 6,000 years. It's kind of the age of oral tradition that's been handed down. But, and this is what needs to be gotten across to students, what happened within a generation of Usher, naturalists were coming out and starting to talk about the rate that sediments were deposited. For example, around old lighthouses or even old Roman ruins, where you knew how old it was. And they began to actually calculate, so many centimeters, so many inches per year, so many furlongs, so many Gunter's chains or rods or whatever those units were they were using. And then look up on the hillside and you see hundreds and hundreds of meters of sediment strata. So, by 1680s and around in there, people were already coming up with much older ages, 10,000, 20,000 years. Newton, 1680s, did calculations on the cooling rate of a sphere and got much older ages, 50,000 years. That was so upsetting, and think links to what's going on today. That was so upsetting at the time that Parliament passed laws based on the legal premise that England had been founded on Christian principles, and anything that conflicted with the account in Genesis was therefore sedition. So these were sedition laws. Actually restricted what could be published, and people like Edmund Halley actually had to withdraw papers and so on. So that was going on around the end of the 1600s. And then, of course, more and more data accumulated. But my point is that I think we can respond to this by teaching that kind of sequence of these simple observations that forced most people, most naturalists, most people with some kind of empirical approach, an open mind, which is empiricism being, in my mind, the opposite of fundamentalism, and force those people to move away from the old fundamentalist view. So I think that's a way to counter that. So all of these are sort of ways of, I don't know, responding to what we are finding in the solar system. And thank you for your time. We still have 15 minutes or so for discussion, if you'd like. 15 minutes, he says. The minutes are clicking off.
Any questions or comments?
Oh, the famous book. You want to look at the book?
So I think everybody here can attest to the fact that it's true that the space exploration has been dramatically impacted and affected and influenced by artwork from previous centuries. And so then the question is that does it still have the impact that it had before? And how can we use it to affect positive impact and change in the future?
I guess I think it does. It's a good question because there's certainly been the problem that, you know, when we didn't know anything, the artist's conceptions inspired a lot of curiosity and wonder, and so you could say, well, we've been there now, so we sort of know what it looks like. And in fact, our IEEA group has sort of evolved into two ends of the spectrum. We're still a continuous spectrum. We talk to each other, but the one end has gone more towards kind of symbolism and even abstract work, sort of inspired by sort of cosmic discoveries and so on. We actually had spent some time in Russia. We were invited by the Union of Artists in the Glasnost period to come over there. And the Russians were much more in that direction. And it was a fascinating conversation because they said, you Americans are just materialists. You're just painting the superficial reality. And we're dealing with the spiritual impact. And they were using all these kind of religious words. It was wonderful. We're feeling the soul of space and so on. And so there's sort of that side, and then the more realist, the Bonistellian side. And so the two terms that have come out of this debate in the IEEA group is the swirlies, who are the swirly cosmic nebula and stuff. They're sort of California people. And then the rocks and balls people. And rocks and balls is basically a kind of an answer or a negative answer to what you're saying, that space paintings for practically all objects in the solar system end up being a bunch of rocks and a ball hanging in the sky. But that worried me for a while, but then I started thinking, well, the Earth, we have this one planet, and artists have been busy painting, you know, really fairly serious landscape paintings for at least 1,000 years. You know, even some of that in the Roman paintings, but and haven't run out of ideas yet or inspirations. And we've got something like 25 objects in the solar system that are big enough to have their own geologic personality. And so I think there's lots of room for continuing to paint sort of exciting aspects of what we're finding out there. And if anything, I mean, I think we're moving towards more and more variety. It used to be Mars was the only possible place to go to look for the questions about origin of life or early organic chemistry. Now we've got Europa with the shell of ice over a liquid water ocean. We've got Enceladus with geysers of water vapor erupting off of it. And we've got Titan with a whole planet full of nitrogen atmosphere and organic chemicals and methane and stuff. So, you know, there's three wild environments right there that may even tell us about life. Yeah.
Just to add to that, there's a lot of 19th century paintings that inspired space art, and those motifs from the 19th century still work perfectly well.
Yeah, and even like the fascination with the geometry and the shadows on the rings and all that around Saturn is still lots of interesting things to do.
Well, you did a painting, I think it was your Neptune and the sun, and I associate that with cotopaxi.
Oh yeah. Well, I did a deliberate Mars painting, which was kind of my homage to Frederick Church of a volcano with a similar shaped cloud on Mars. You know, kind of a similar layout. I've done a couple of things like, well, it's like that Bonistell painting with the Bonistell rocket in it and so on. Yeah.
Thank you for this. Is actually, we've got one question ahead of you.
Oh, I'm sorry. I didn't see. That was lost in the
You
glare.
didn't make any comments about the way NASA has sometimes colorized, like following Ted Turner. I wonder if you could comment on that, as whether you think it's legitimate or illegitimate. Or
The whole issue of color is a real problem, and right after the first Voyager missions, in fact, I don't know, that might have been the issue of Smithsonian that you were talking about. I had an article, I can't remember what the subject was, but that month, Smithsonian and 2 other magazines all used, as I remember, the same image, which had to do, I think, with one of the eruptions. And it had been released in false color. So this is like the early 80s. And you could just see all the art editors in downtown Manhattan were having lunch together, you know, and there was a zeitgeist of what was a cool thing. And purple and green and orange and stuff coming from spacecraft was cool. So they all put this false color picture on the covers of the magazines of Io around the time when those volcanoes were discovered. And I thought that was terrible because, you know, to me, I want kids and to get a sense of what this is really like and not some jazzed up colors. Now, there were reasons for doing that, but I mean, for colorizing them. And you know, for a long time, and still today, maybe a little less now, I mean, scientists were using these arbitrarily assigned colors to show things that, you know, could have been done with contour diagrams or something. You know, the brightest is orange and the next brightest is green. And, I used to complain when I did my textbook to some astronomers who would provide the then new kind of infrared visual imagery, say wavelengths that went from visual into infrared. And when those first started coming out, since infrared isn't a visible light, they'd arbitrarily assign green and purple and so forth. And I said, look, you know, why don't you at least take the longest red wavelength and make that red and the next longest one orange, so that kind of the visual sequence is at least the same as what we're used to seeing. Now that's kind of one aspect, and I think you're probably talking more about adding estimated colors to images where you don't really have the full color. I mean, I don't know. Mars missions, for example, is often like the red and the blue. And then they say, well, we have a general map of Mars where we understand what the greens and the intermediate colors would be in that general region, so we'll just stick that into this detailed picture as close as we can to a true color picture. And usually they say that. But the most profound part of it is that, you know, as has been talked about before, you know, nobody in the future is going to be able to believe any photograph that you can't go into a library and show that photograph was published before, say, 1980 or 1990, because you know, anything could be photoshopped now. So there's a famous, the Russians were doing this, and there's a famous, wonderful picture of a group of cosmonauts, and I think the story was that one of them had died, but at any rate, they didn't want to admit his existence, so there was this kind of lineup, and so the busy airbrush artist got to work under assignment and took out this guy. And I guess there was one version of the picture where there was a brick wall behind him, and another version where there was a window or something. There's a famous version where, I mean, imagine these guys stand up, and here's my buddy here, and I've got my hand around his shoulders, and they take out the person, but they took out this person, and this guy's still in the picture, and there's this ghostly, disembodied hand on his shoulder because the artist did not. So sometimes they get caught. But imagery is going to mean something totally different from now on out.
Specialists who did photographs of the reviewing stand in Red Square, where certain people would disappear.
Yeah. And we, you know, in a way, we're having a little more of that in this country because it's kind of like revisionist versions of, I don't know, you know, take the subject, Iraq or whatever. But,
Read any Japanese history books recently?
no.
Hey,
No.
Thank you for this. This is wonderful. Full
Oh
of
yeah, I was glad actually he interrupted you because then you got to Twice.
Twice, I'd like to ask you about either the existence of paintings of the following types, or whether you have any thoughts about paintings of the following types, about other senses of space art. Because I'm struck by the things that so far we haven't seen this evening. No images, for instance, of terraforming landscapes, or of what, I think of Biosphere 2, for instance. What if we tried to create, what type of architecture, what kind of aesthetics, what kind of civilizations might we want to create? What happens if we turn Christo loose on Mars, or for that matter, either imagined or actual earthworks?
Yeah, your question is great, and it makes sense that subliminally sort of thinking about beauty in the solar system, I restricted that to the natural objects pretty much, but there is a lot of art of the very things you talk about. There's Mike Carroll has done probably the most reproduced version of a terraformed Mars, where you see kind of these oceans, and it's an odd picture. I was just talking to him about it the other day, because the versions I keep seeing are very dark in the southern hemisphere, and I think partly what's happened is it's been reproduced so many times that we're not sort of getting a good reproduction from the original. But he said also that he had, I guess he was trying to show the dark markings or something there so that it was fairly dark. But anyway, it's a little sidebar, but certain images get very popular and they reinforce themselves. And I see this even in my own stuff. There's a painting I did a long time ago of the origin of the solar system. And that's been reproduced enough that when one of my paintings of the origin of the solar system, some magazine calls up, and they always want that one. And I'm saying, I've got this newer one here, yeah, but we kind of like. And so, one painting, I mean, here you think, oh, these must be equally good, but, this one gets 25 reproductions, this one gets 25, and all the ones in between, don't get reproduced at all. It's really funny. And then in terms of space architecture, there's, do you remember Jerry O'Neill's books with, there was, I don't know who the artist was, but the inside of the big space structure that he had, rotating cylinder, wasn't it? So, there's certainly been a lot of that. And that grades into also the science fiction artists are often the ones who get called on to do that. And it reminds me, your comment about space architecture is that Bonistell did this really odd, it was a really bright idea, and it must come back to his architecture training, but he did a painting in Conquest of Space or Exploration of, I guess it was Exploration of Mars, which was a Greek temple. There was kind of an A and a B version. The Greek temple, the A version was, I don't know if it was painted as on Earth or if he actually transported it to Mars, but it was under Earth gravity. And then he did, what would a Greek temple look like if you had the same structural, strengths and everything, but under Mars gravity? And it's all, real tall columns, and it was the same temple, but sort of redesigned to put the same stresses on the base of the column and all of that. So I don't know if that answered your question, but yeah, that, and in a way that speaks to your question, because as new architectures go out there and new expeditions and new structures, there's going to be a lot of really interesting things to reproduce, whether it's photography or painting or whatever. But those are going to be sort of interesting art objects of their own. And so there's a huge future for all of that. We're done. Good. Okay. Thank you.